In this video, we're going to look at problem number 3 on the compound, find an area and perimeter of compound figures. Again, this is number 3, and really what I want to do here is just do the area. We'll worry about the perimeter a little bit later. So this is a compound figure, and the key aspect or attribute of a compound figure is that it consists of other figures. So if we look at this guy, it's kind of it looks like a garage or something. I don't know what it is. But if we look here, look for shapes that we recognize. And I see right here, there's a rectangle, yeah? Because we're trying to find the area. There's no way we're going to find the area of trying to do this whole thing like it's some kind of a parking deck or something, parking garage. So we have to split it up into the parts that we do know. So there's one rectangle there. It looks like it's the same size rectangle over here, right? Both of these guys are 5 by 16, right? So they're both the same size. And then also the top of this thing, so there's another rectangle, or there's a triangle here that runs all the way across and looks like this, yeah? So all we have to do is we have to find the area of this guy, the area of this guy, and the area of the triangle. And if we add all three of those together, then we're home free and we can figure out the area. So since we're just doing the area, and we have a triangles and rectangles here, I put up here the two formulas for the area of a triangle and a rectangle. Remember, the triangle is 1/2 base times the height, and the rectangle is length times the width. Let's do the easy one first. We'll do the rectangle, right? So this rectangle here, again, the area of a rectangle is length times width, and in this case, the length is 16, right? The width is 5. So these two, 5 times 16, all right, that's going to be 80. Remember, we're talking area here. How many squares fit inside this figure? So it's going to be, since we're talking about meters, it's going to be square meters. So this one is 80 square meters. This one we said was the same size, so that's 80. So we're 2/3 of the way through. Now we just have to do the triangle, that big guy that looks like this. Again, the area of a triangle is 1/2 the base times the height. Well, the base remember, it runs across the bottom here. That's the base, and the height runs from that opposite vertex and runs straight down. So in this case, we know the height is 3, but it's not exactly clear what the base is. But if we look at the diagram, we can see that the base, this part of the base of the triangle, is the same as this guy. Right, they're both 16 meters across, and the same thing over here. There's 16 meters here on this side, so I know that's the 16 and 16. That's 32, and then I have this chunk right here, which is another 19. Right, so if I take the 16 and the 16 and the 19, what's that? About 51 meters. So the whole way across this base is 51 meters. Now I've got the height. Got the height here, I've got the base, and I can just plug numbers into the area for the formula for area of a triangle. So remember, the area of a triangle is 1/2 base times the height, which in our case is 1/2. The base is 51. The height is 3. Right. So let's see. Let's move this up here a little bit. Right. So the area is going to be 1/2 of 3 times 51. Right. 3 times 51. What's that, about 153, all right? And then we just need to divide this by 2. So 153 divided by 2, or multiplied by 1/2, the same thing, right? What's 76.5? 76.5, yeah, right? 0.5. And again, this is area, so it's 76.5 square meters. So now we know this, and the figure at the top, the triangle, 76.5, so we can make some sense out of this whole mess. We have 80 meters, we have 80 square meters for the two rectangles, 76.5 for the triangle, all right, 0.5, 6, 16, 23. So the area of the entire figure is 236.5. And again, remember, it's meters and it's area, so it's square meters. Done.